Welcome to the FutureG workshop. This is the second edition of FutureG 26. It's our pleasure and honor, I'm Syed Rafi Hussain, by the way. I'm an assistant professor at Penn State. I work on cybersecurity, mostly 4G, 5G, cellular network security, Wi-Fi, and satellite. So I have a great pleasure to serve with Vinod Yagneshwaran from SRI as a program committee chair for FutureG 26. We have also an steering committee where we have Yangdai, Jiqiang Lin, and Phil who are here too. I'm not sure whether Jiqiang is here. I didn't see him yet. But we formed this committee last year, and it was a great success with the participation of many great authors and also panelists from Department of War. So since we have a technical glitch, so we cannot show you that what is in the slide, but as a whole, why FutureG? So we know that FutureG actually is shaping the future. So with the advancement of the many technologies in cellular networks, in the physical layer communication technologies, sort of AI native design, cloud native architectures, and also the sort of a merge of terrestrial and non-terrestrial networks, the next G is expanding in a rapid space from the previous generation. And with this rapid growth, we have more attack surfaces, right? So we need effort from researchers, from academia, from industry, from government to see what are the new emerging threats, how we can address them, and how to build next generation solutions for them. So with that vision, this year, in line with the previous one, we also sent out the call for paper, and we received 16 papers in total. And we had to just reject 2 papers. And significantly, the number of full paper submissions or long paper submissions were, this year, it was really high. So we accepted 6 long papers and 3 short papers. And of course, we had a lot of review tasks. The whole review process was intense. Each paper was reviewed by at least 3 reviewers. So we had 19 program committee members who dedicated their effort towards this. And also, this year we introduced shepherding approach to make sure the quality of the final camera ready version is up to this NDSS conference. So thanks to the shepherds and all the reviewers for this hard job. So quick thing that we have this the full day workshop, and we are honored to have 3 keynote speakers. Dan Massey from NSF, and Gavin Horn from Qualcomm, and Makhan from Ericsson. They will be here for our keynote speakers. I'm sure you will be learning from them, and you'll be enjoying their exciting what they have been working on, and what is the sort of future they are actually looking for FutureG. And of course, similar to last year, we have a panel on 6G security and privacy, which will be moderated by Orup from Idaho National Lab. And the 4 esteemed panelists are Ted Woodward, Martin Weiss. 5 panelists we have, Professor Nuria from UCSD, Ken from Ericsson, and also Jorge from Nokia. So I'm sure I could not show you the here on the screen the agenda. So 9:15 we will have our first keynote speaker. Then after the keynote speak at 10:50, which will end at 10:15, then we'll have a short break, and then after the short break we'll have a paper session and followed by lunch. Then we'll let you know what are the rest of the agenda is. And as I said, all of these would not be possible with the authors' contributions, and also our the jobs that sort of a peerless job that all the reviewers and shepherds have done. So So I was supposed to show all the reviewers list here, but I could not do it right now. But thank you so much for joining this FutureG workshop, and I hope you'll enjoy the rest of the day. Thank you. So.
So while he's setting it up, let me quickly introduce Dan, who's going to be the next keynote speaker. Dan is a program manager at NSF as part of SAIS. I'm sure everybody here knows Dan, but I'll provide a brief introduction anyway. He has a wealth of experience. At SAIS, he leads the programs in the intersection of cybersecurity and infrastructure. But prior to that, he was at OUSD, where he was one of the brains behind the 5G convergence program, as well as the Operate Through program that most of you are familiar with. And prior to that, he was a professor at University of Colorado and Colorado State. Yes. So, as well as a DHS program manager. So, right. Thank you, Dan.
Thank you. All right, thanks. All right, let's see if I have better luck with the laptop here. Let's see. Okay. All right.
And then give me a second.
Sounds good. Okay. All right. So it's so this is a fantastic looking workshop and program, and so I'm going to take advantage of being the very first speaker. I'm going to steal a little. Going to kind of promote pretty much all the talks coming up, because you've really got an interesting mix. But my main theme here is going to be something I want to kind of try to push folks toward. It builds on what we did with Operate Through. It builds on some of that. The title of the talk, when it pops up here, is the infrastructure is your adversary, not your ally, right? And so I think that's kind of an important change in the way you think about the threat model. Is we've got a lot of good stuff, but I really want to push it. There we go. Okay, so here's what I hope to get done today. Right, is I want to give some motivation and review of the FutureG security landscape. We can use the papers in this workshop as a great way to do that. Then I'm going to kind of present my claim that why should you assume the infrastructure that we all operate on, that I'm on right now, is actually the adversary, not the ally, right? And then if you do buy that premise, what would you do, right? I mean, how does that change what we think about? So to get started, let me talk a little bit about, all right, so what are some of the challenges, right, for, and you guys know this because, you're the authors of these great papers, but, when we talk about FutureG, what we're really worried about are legacy challenges, right? We're going to have a great talk on, remember the old DNS system, right? This is, decades, right? Well, old and still in operation, but not what we think about not what we typically think about when we think about FutureG. But you'll see later today the great thing that DNS actually plays a huge role in the underlying control and the operation of the system. I won't steal thunder from any of the talks that I point to here, but if you're going to build a secure 5G network, you have to overcome these old challenges, right? And you have to build on, I don't know what bozos did the DNS security extensions, but there's probably more work that needs to be done there, right? Okay, but then going the other direction, right? We're not just looking backwards at DNS or legacy systems, and we'll see this, as we bring on IoT devices, as we bring on V2X communication, right? And we see the emergence of quantum computers. We've got to be thinking in terms of post-quantum cryptography. Right? How do you build that into the 5G system? So you are simultaneously, on the one hand, looking for how do I improve working with the old domain name system, and on the other hand, looking forward to the post-quantum world where you've got to adapt, and we'll see at least a couple good papers on how you have to adapt to the newer piece. So this makes 5G security or FutureG security challenging because we're looking, both backwards and forwards. But we're also looking at both the higher and the lower levels, right? So when we talk about 5G security, what are we talking about? Are we talking about the physical, the PHY layer? Are we talking about the actual RF transmissions? And we have to be, right? And you'll see that this is a fundamental constraint we're not going to be able to get around, right? There is finite spectrum, right? There are issues with the spectrum, and we have to deal with those issues with the spectrum. We'll see that there's challenges on, how are we going to coordinate use of the spectrum, right? We're going to look at we've got to look at those kind of things. We're increasingly, relying on the idea that we'll be able to share spectrum in a reliable way. I'll pick just briefly on a talk you'll see coming up from Arup here, because and so what they're going to look at is they're going to look at what can go wrong with some of the spectrum sharing, and I'll leave all those details. And one thing I noticed in that paper is that they did a really good job of saying, look, you have to assume that there's an insider attack or a compromised system. But I would challenge Arup to take that one step forward. I don't think it's just an insider attack or a compromised. I think it could be the intention of that system operator, that we shouldn't just assume that, wait a minute, I have to worry that this guy got compromised, or this institution got compromised. I have to worry about the institution might actually be intending to be my adversary. So I think those makes for some interesting challenges, but you've got to be thinking along the level of the hardware, right? So, all right. So 5G, FutureG security, 6G security, it's both, looking at new things like post-quantum crypto, and it's looking at our traditional classic infrastructure, the DNS, and it's looking down at the physical layer, the RF, the PHY layer, but boy, it's also stuck at the high layer, right? As we see with O-RAN coming forward and putting in all this potential here, we are diversifying the software from multiple vendors. Right? We have to look at the software supply chain. Again, some more, looking forward to some other really interesting talks here. How do you secure that software supply chain as that supply chain gets more and more diverse? And I'm a big proponent of Open RAN. I think it's a great thing, but that is going to make more challenges on the software supply chain. It brings the diversity, but it also makes the challenge of validating that software more challenging. Right, and then we've got things like like near real-time RIC that are going to incorporate in AI, and it's going to adapt our infrastructure at a time scale that humans can't keep up with. Right, and that's probably a good thing as long as it's working correctly and it's working in our favor. But now we've got to worry about, well, what are the security challenges, and if we're going to do that, we have to make sure that we're incorporating secure AI, not just AI. But that raises another challenging question. So, sounds great. What's secure AI? How do you? All right. So we've got just a few little challenges, but then of course we can't get away from our cybersecurity fundamentals, right? So. Right, if you look at this, right, for any system, and this applies to FutureG, 6G, 5G systems, your security actions are only as good as the data on which you're basing those actions. If I believe I'm under attack, and so there's great work, I'm looking for Phil here, but there's great work on telemetry, right, to better understand on what my data looks like. If I have the wrong view of what's actually happening in the network, my security adoption can actually be a negative, not a positive, or I simply fail to observe that. So you need that. I was pleased to see there's a challenge. There's a great paper in here on as you talk about building in AI, right? And AI allows edge devices, allows other things to signal information into the infrastructure so it can adapt. That's a classic input validation problem. What if I send in the wrong input, right? Am I sanitizing, am I validating my input? Right? This is no different than our good old buffer overflows, right? Way back, when you're going to read something in off the web, I'm reading in a student ID number, 9-digit student ID number, and the bad guy sends in a massive buffer, 2 gigabyte buffer with embedded code and all this. We've all seen the buffer. We've all probably taught that in buffer overflow class at some point. But the same thing applies here, right? We've got to do input validation as we're sending things into this AI, into this near real-time RIC. The exciting stuff there. We need continuous monitoring, and we need authentication and re-authentication, right? This is no longer like, I logged in with my nice little PIV card this morning. And so, I will periodically have to re-enter my PIN to stay online. But now we've got to push this into the world of thousands, millions of sensors. That not only does that create more of an authentication problem, but I need to authenticate more quickly because these are, re-authentication. So there's some great work on re-authentication. And I could go on with we need least privilege, we need segmentation and isolation, we need fail securely. Basically, if you go through the laundry list of if you were to teach intro to cybersecurity, all the principles you'd put up there that we have to do, they all apply, right? So it's a challenging space, and I'm going to try to make it worse, right? Well, before I do that, let me just say, we all, and again, I'm kind of preaching to the choir here a little bit, but we all know what can go wrong when we get that wrong, right? So obviously we can have denial of service. Right? So we simply can't get onto the network, we get kicked off the network. That is the least interesting issue. This was part of when we were doing the operate through program, right? One of the questions we already got is we got like, wait a minute, okay, so we're operating on an untrusted network. What happens if the untrusted network just turns you off? And my answer to that was always, that is my best case scenario. I am not, I am, of course, it's a valid concern, but I am worried about being disconnected from the network. But I'm much more concerned about staying on the network and being manipulated in various ways. Resource exhaustion that can drive down my battery, that can consume resources. Right? So I'm worried about what happens with that resource exhaustion problem. Not that I got kicked off the network, but that I'm on the network. In fact, we'll see in some of the papers that you can actually do quite a bit of damage to the physical resources of devices like this, based on some of these things. I'm of course worried about interception misdirection. I think I think I understand the path I'm communicating across, but I'm completely mistaken in what I think is going on there. I've got the ability to intercept, and so you're like, okay, but look, I'm going to encrypt my data, right? So who cares? Who cares who sees it, right? And so there's this classic security problem. It's a little bit of it's more of an analogy than real, but there is a little bit of truth to it. Have you heard of the problem called the pizza delivery to the Pentagon problem? Okay, I see a bunch of nodding folks, right? So here's kind of the basic premise, right? Is you could sit at Pentagon City parking lot, this shopping mall across the street from the Pentagon, and you can simply watch pizza deliveries, food deliveries going in and out of the Pentagon. Why would that matter, right? Well, think about it's a Friday night, and you see a strangely large number of pizza deliveries into the Pentagon. All right, well, so what does that mean? Now, notice I'm not in the Pentagon. I'm sitting in my car in the shopping mall across the street. And what I'm seeing is sort of an interesting bit of data there to say, why are there so many deliveries happening tonight? It could mean that it's, Alice or Bob's retirement party. It could also mean that whatever operation we thought was going on is now going on late at night and we've got people there, right? So think of that Pentagon delivery problem now amplified into who's communicating with what volume, even if I don't know who you're directly talking to, just the volume of information, the pacing of the information, that alone can give away a ton of information, right? Observability, can I know where you are on the network? This is on the DoD space, this is a huge concern, right? And so it's, in fact, in this case, an adversary might like to not deny service to the network, but keep me on the network and pinpoint exactly where I am. You can have interference across other systems, right? So maybe the intent here isn't to take out myself, but what if you can get it so that I am manipulated into transmitting what I think is a valid transmission, but is actually overflowing and causing another system to go down. If I'm given a false message about, hey Dan, you are now clear to transmit in this block at this power at this time, great. But what if that message is actually the other way around, intending for me to interfere with something else? So the target isn't so much Dan's phone. The target is, let's get Dan's phone to take out the critical system down here at the port. Right? All right, misrepresentation, violation of service agreements. Right, we've all got this. Especially at the larger scale, we've signed SLAs. We're getting that SLA from the network. That might be a misrepresentation. That might be intentional violation. How do I know that? And of course, how does all this get to the compromise of the edge devices? I think with all this, I suspect nothing in here, there's nobody out there saying like, oh, I didn't know about that one, right? I mean, I think these are all, I think if I read your abstracts, I think, everybody's mentioned at least 2 or 3 of these in the abstract of their paper. And there's more. But this is why we need to care about the 5G security and FutureG security. Okay, so if we've got problems, we know that we've got these challenges. So one thing we always need to do, one step is, identify your assets, identify your adversaries. So who are our adversaries? Well, really any device capable of transmitting in range of my system is a potential adversary. It's an interferer, it's somebody being manipulated to cause other things, it's somebody gathering data. So, that space is pretty huge. Anybody who can transmit. I'm worried about false control messages. And I'm worried about false control messages coming into my infrastructure, but not just locally. I mean, that can come from pretty much anywhere in the world. We'll see with, for example, some DNS stuff that you can manipulate, completely remote. You can manipulate, and you can do quite a bit of damage to the control system of a network. Right? So I've got those guys. The bad guys are anywhere within range or anywhere that can talk to me. And that's pretty big. And I've got to worry about, well, what happens if there was compromise at the supply chain, in the hardware or the software? The device itself has an embedded issue in there. The software has an embedded challenge in there. I've got to worry about getting that into my infrastructure. So and of course, I've got infrastructure that might fail to properly implement the security-related features. So maybe we've got an operator who decided, that optional security parameter, that's not important, right? And that can cause a lot of challenges, right? There might be an operator who says, yeah, you know what? No, that one's important, but I implement it in an incorrect way. Right? And so you're trusting not only that the folks that network you're relying on are implementing the appropriate security features, but they're implementing them correctly and they're testing them. And then, of course, as I mentioned with Arup, right, the insider attacks are critical. And I think many of your papers, if not all of your papers, mention the possibility that there's an insider attack. I've got that embedded software that got in there. I've got a compromised operator. I've got a compromised device. I've got all that. But here's where we might start to disagree. So at this point, all this should sort of be like, yeah, Dan, we've heard all that before. If nothing else, it's a little bit of incentive to really look at the more detailed papers you'll see later in this conference. My challenge is going to be, it's not just an insider attack. You've got to change your thinking so that infrastructure, that MNO, that equipment vendor, and I know there are equipment vendors in the audience and probably some MNOs in the audience. This is not a direct attack on you as an individual entity, but I think we as a community have to assume that that's our potential adversary, not our ally. It's not that our MNO, our underlying infrastructure, our operators are there to help us. They might be, and they often are. But they might also be there to try to shoot us down. And so that's an important pivot, right? So don't just claim in your paper that, oh, I've got a problem here that there might be a compromised adversary or a compromised insider. It's worse than that. The whole system. So like, okay, but wait, okay, so why shouldn't we trust the, this sounds like craziness, right? This is, paranoia here. Why shouldn't we trust the infrastructure operators? We use them on a daily basis. I mean, they do great jobs, right? But I want to remind us that we're a security community. And so that's the wrong question. It's not why shouldn't we trust the infrastructure operators? Question is, why should we trust the infrastructure operators? Right? That's the way we need to think from the security perspective, is we don't say like, you know what, I love, I'm not going to name my particular MNO, but I like my MNO. They do a good job. I've been quite happy with them. But that doesn't mean I should trust them. They could be out to get me. Okay, so I want to kind of shift that thinking to why do you want to, what might you want to do there? Okay, so why wouldn't you trust your direct provider? Right? Okay, well, so your direct provider has a diversity of equipment vendors, and that only increases with ORAN. So if you're in there and say like, I really like XYZ, well, XYZ is equally dependent on the components that make up their network, either with their explicit knowledge or without their explicit knowledge. That equipment can be out to get you, can be out to gather information. It can be programmed so that it will do a particular kind of attack. Right? We've got increased use of AI in the control plane, which is great. Right? But that means that now whoever's managing that AI is in sense operating my network. Right? And we're not sure we know how to do that. I'll do a quick tangent here. So one other thing that we're always interested in, we've at NSF, we now have a new, along with the National Academy of Sciences, we have a new workshop, a new study coming out to say, what does it mean to do secure AI? What? So hopefully whatever MNO or whatever equipment vendor or whoever is using secure AI systems as they bring those in. What is a secure AI system? We had I'll pick on my not any of the DoD colleagues here in the room, but in a previous DoD meeting there was a system going out there, and we raised the question of like, okay, that's really AI dependent. How do you know that that's correct? And they came back with a great answer to say, well, we're going to red team it before we deploy it. I'm like, great, what's your red team? They're like, we're DoD, we have a ton of really good red teams, and they have really, really good red teams. And we're like, do you have an AI red team? What does the AI red team do? Now, I can bring my red team in there, and I can say like, does your, we'll keep it in the 5G FutureG space. Is there a buffer overflow in this thing? We'll see a paper here. Is there input validation on what's going into that? And all those are great, and you should do that. But is that really what we mean by securing AI? I'm worried about the training data. What if I put in the wrong training data? Right? What if I'm out here in San Diego, and what I want to do is I want to detect the difference between a tourist boat that's happily taking people around and maybe a first responder boat that should get higher priority. Right? And so I've trained my AI. I've got autonomous drones watching the network, and I've trained my AI to do that, and I can look for, is that AI working right? What if the training data has indicated that everything with a blue sail is actually a tour boat? Right? And everything without a blue sail is a first responder. So you can then deceive the AI by doing something as simple as putting a blue sail on your boat or changing the color of your sail. Now, how would we know that? How would we know that AI, if this was simple static logical programming, we'd say like, is there an if statement saying if blue sail? That's not what the AI did. This built this into a complex system, right? And so how do we, so we're very interested in what should we do with AI. Just to kind of, if you know, folks can always approach me later if you're interested in sort of joining in on this sort of study. So I'll give you two extremes. The one extreme is to say AI is a buzzword, right? We're cybersecurity people. We've known how to do cybersecurity forever. We still know how to do cybersecurity. The problem here is your classic least privilege, separation, input validation. There's nothing really fundamentally new in AI. You just need to apply what we already know for the cybersecurity principles. So there's one camp. Say like, yeah, cybersecurity for AI, it's just cybersecurity. Other camp says, no, wait a minute, it's fundamentally different. There are whole new principles. There's many principles that don't apply. There's input. Well, let's look at does input and validation really apply? I mean, maybe the power of AI is that it can take any kind of input. It can figure out whether it's good or bad. And we actually have this active debate within NSF about in scientific data. Do we want better curated, more accurate scientific data feeding into our systems? Or do we want any data we can get as long as we can make some assumptions about how accurate it is? So maybe I want to go the other direction. I don't want better, more secure, better curated data. I want more data. And we could never sort that out as people, but AI could. So we got these two camps, right? To say, it's just regular security? No, it's completely different. Like anything, it's almost certainly somewhere in the middle. There's a lot of traditional cybersecurity we can apply. There's probably some new challenges that we have to think through. Okay, but so AI for, now the other thing is, if we go back to sort of, why does Dan think his MNO is out to get him, right? Well, they're not really out to get me individually, but I am not a meaningful part of their economic system. They actually are. This is not they're bad. They have fiduciary requirements if they're publicly traded companies. They can't say, you know what, this is going to cost us a lot of money, but it makes Dan safer, or it makes my users safer. There's limited value to the individual customer. There is real incentive for the MNO to make their business. Frankly, if they don't do that, they will go out of business, and their customer will suffer in the end. So you got to keep in mind that while they want to make sure that you get service, they have their main input objective is not to provide you with good service. It's to provide good service for themselves as a company. And that's not a bad thing, but that's the reality. Right? There are regulatory requirements that restrict or potentially dictate what actions they can or can't take. Right? So hopefully some of this is making you think like, all right, I'm not going out there and saying, be afraid of your MNO or be afraid of your equipment vendor or be afraid of your operator. But I hopefully am kind of raising some things to say like, maybe I need to be a little more careful and not just say, I know this is going to work. Okay, so, all right. So that's just my MNO. The other problem here is the interconnected nature of the infrastructure. Right, so my MNO has roaming agreements, and I can roam. As we go somewhere else, I can go anywhere. Right. In fact, we have an example. I'm not going to name the specific vendor, but there's an example here where there's one vendor that is preferred because of their choice of one MNO that's preferred because of their choice of equipment vendor, and they have a guarantee that operating here in San Diego, you will never be using a particular kind of equipment. For that same group, if you drive an hour south of here, you will automatically, without knowing, go to their preferred, well, with knowing, but you will automatically go to their preferred roaming partner, just south of the border here, and you will be entirely on the equipment provider that they promised they will never deploy here. Right? That's, and so you've got this challenge to say like, all right, I'm going to make sure that I got to make sure that the network I'm operating on only has equipment I trust or I like or works with me. But you're going to move around, right? There are economic incentives that drive information sharing. There's regulatory requirements that drive information sharing, right? We'll see later about how we can accurately share, new chunks of the spectrum. To do that, I have to share information, right? And so that only makes this challenge worse. And so maybe what I'm doing is sharing the information for the perfectly valid purpose of making sure that we don't collide, making better use of spectrum. But somebody else sees that information as really interesting data that they can manipulate in a different direction, right? You have to worry about the balance between cooperation and competition. My MNO needs to cooperate with the other MNOs, right? And they do. But my MNO, I would assume my MNO, if they could put their other MNO competitor out of business and take all their customers, they would do it in a heartbeat, right? And so there is this tension to say, like, okay, maybe you're good friends with the operator at your MNO or the manufacturer of the equipment vendor, but they're working in this broader place here. Right? There's another interesting challenge of the influence of standard bodies on the MNO. Right? If this is the standard, you need to implement it, whether you agreed with it or not. Right? If this is not standardized, you may not. Also, there's the influence of what is the equipment vendor, what is the MNO, what is the operator, what is the whatever component you're talking about. What's its influence back on the standards bodies? And that might not be in your best interest. Right? I think we all know sort of the difference between, there's something that's standardized, mandatory standardized, pretty strong. Likely it will be at least claimed to be deployed. Implemented correctly, we'll have a separate conversation about it. Optional standard is a massive difference than mandatory standard. There's a number of optional standards, going back to good old IETF days. In fact, looking at DNS and DNS security, there's a number of optional things which are really good, which I don't think have ever occurred outside of a lab. Right? And I think that's true as you see this. So, you might say, like, look, no harm, no foul. We disagree about this part of the standard. Let's just move it to optional. It's not that far off moving it to dead. And and then of course, if it's not in the standard at all, we've got another challenge. Okay, so with all that, I want to leave you with this sort of. I want to convince you that the compromised insider and adversarial infrastructure are not the same thing, right? And so I've tried to pick up. So let's think about this. Say, like, if you're like, look, my paper already covers this. I talked about the infrastructure being compromised, And so you said, look, the bad guy is in there. He's the critical network operator, right? So that person can exfiltrate sensitive data in violation of the organization's policies. That's true, right? And that's a big threat. But it's a different threat than the organization itself maliciously designing and implementing what the security policies for what it seems to be sensitive. I don't think these two are equivalent. I think if you take the case of there's a bad guy in there trying to exfiltrate data, that's a damaging attack. That's the problem we have to deal with. I think it's worse when the organization has an adversarial intent to exfiltrate the data. These are not necessarily equivalent. This is a harder problem. I'll give you a couple other examples, right? My compromised insider, my bad guy, can come in and they can disable key security features. Right? So that's a problem. We have to worry about that. My adversarial infrastructure itself, it simply blocks key security features from even getting out into the standards bodies. Not only turning it off for itself, but turning it off for everybody else. This is a different threat. These are not equivalent threats to say, oh, I'm worried about this guy, I'm worried about the adversarial infrastructure. I think the second one's more damaging, right? That compromised insider, can manipulate logs, it can remove activity traces, they can operate quite successfully for quite a long time inside the infrastructure. If the infrastructure itself is adversarial, they define and control the logs. This is a much harder problem to detect than that. Now, this is not an easy problem to detect. I'm not claiming that, like, don't worry about it. A good infrastructure provider will catch them. Likely they eventually will, hopefully. But it's a whole different thing if the network itself, the operator itself, is trying to do it, right? And of course, that our insider acts to evade detection by the administrators, right? But what if the infrastructure itself is intending to do whatever negative consequence we're looking at? Right? Well, in that case, the infrastructure itself is acting to evade detection by the customers and or regulators. That's a harder problem. So I think if the one thing you take away, I think a lot of you did a great job of incorporating insider attacks. Could you take it one step further and say it's not just an insider attack, it's the whole thing is out to get me? Only the paranoid survive kind of approach. Okay, so all right, my last kind of assertions, and then I'll give you a few things about what you might do to actually address some of this. So, okay, so I think I recommend that your threat model must assume multiple players at all levels. Right? There's multiple MNOs, there's multiple equipment vendors, there are multiple RF environments. All this is gonna occur. That's a fact. You can't remove any of those facts. That's just there. And I think, having looked at all the great papers that are in this conference, I think everybody would sort of agree with that top one. Right? I'll go down and say that threat model must assume all players act in their own self-interest. Again, it's not that my MNO is secretly sitting around a table somewhere saying, how do we take down Dan? Right? But they are working for their own advantages, which may or may not align with me. And when they don't align with me, they're going to do what aligns with them. And that's the way that works. It's not sufficient to assume that insider attack is equivalent to adversarial infrastructure. And I tried to give like 4 examples in the previous one about why that might be different. And then the other thing you say, like, okay, I'm convinced, right? The infrastructure can be out to get me. I'm not going to rely on the infrastructure. I'm going to build my own. Right? No, you're not. You are not going to be able to build your own. First, right? We need the global connectivity. Right? I can't say like, you know what? I'm going to build my own MNO. Well, I don't think I'm going to have a global MNO that I can, and so even if I'm building my own piece there, even if I'm building my own private 5G network, private 6G network, right? That network is still including infrastructure from vendors. Maybe I'm not. Maybe am I building the? I guess maybe with a Kudu I am. I'm building the whole thing, right? But I think I think there is a. But even there, I'm relying on software. I'm relying on components. So you have to assume that you don't own and control the whole infrastructure. So if the approach is, all right, that part can't be trusted, I will just build it myself, I don't think you're going to get very far. All right, so that's kind of the, if you take anything away from the talk, I hope you take that sort of away. Right. Then I wanted to just end with a couple things here to say, like, okay, the classic bad cybersecurity talk is you're doomed. Don't do this. Don't turn on your laptop. My favorite example of this is the first time I went to a Black Hat conference. I went and I showed up as a happy little grad student. I'm at Black Hat. Opened up my laptop. Got the first thing like, do you want to join the Black Hat network? Wireless network. And then it was like, no, are you kidding me? I mean, and so I closed the laptop, put it back at the hotel, did not open it again until I got back to my university lab. But that's not really a valid answer, right? You can't say you can't say I'm just going to stop, right? So if you're like, if you believe me that okay, maybe I do need to assume the infrastructure's out to get me, stop using the infrastructure is not the answer. So okay, so and then one thing this talk is not saying, and I want to make sure I put this up here, This is not saying the infrastructure's out to get us. There's no value in making all these improvements to the infrastructure. There's huge value in making improvements to the infrastructure. If we can mitigate the DNS vulnerabilities, if we can incorporate post-quantum algorithms, if we can improve frequencies to sharing, security and analysis, if we can validate the AI inputs at all protocol layers, if we can et cetera, all that is fantastic, important work, and we need to do that. So the answer here is don't abandon the infrastructure as there's nothing we can do. We make it as good as we can, but we never assume it's going to be perfect. Right? We can always promote security and standards bodies and best practices. Right? And this is a key thing. Right? Required security features are demonstratively more effective than optional. Right? And the more we can do to actually implement security, advocate for security standards, I know a lot of you are actively engaged in that. That is hugely important work. Neither of these gets the infrastructure to the point that it's trusted, but it makes it better. Right? So then, okay, what do I do here? So I think the focus needs to be on telemetry, data sharing, and an independent validation. I think we actually have a huge potential, not just to say, I trust what this infrastructure is doing, but to monitor, to observe, to detect, even from my single little phone down here, combined with AI, combined with data sharing, combined with this, can actually tell me quite a bit. And so I need to assume the infrastructure is actively adversarial. I can gather data to detect issues and assess the risks so that I understand what kind of infrastructure risk I'm operating under. I want to make use of all the infrastructure. I don't want to say, this guy's good, this guy's bad. I want to say, this guy has these issues, this guy has these issues. Let me use them both. Maybe by using them both, even that untrusted infrastructure, I can actually make a more trusted overall system. Right? I need to actively modify my behavior based on the risk level. This was one of the fundamental principles behind the old operate through. It wasn't saying, fix the infrastructure, which is a great thing to do, but that's not what an operate through is doing. It wasn't saying, avoid that infrastructure, because you can't. It was saying, understand what that infrastructure is doing, assess risk, modify your behavior accordingly when you can. Sounds good. Is there actual example of that? So there's a couple. I won't steal the thunder from this. Some great telemetry stuff that will actually be talked about later in this session, in this workshop. But I'll point to one that came out of some of the funding that it was joint OUSD, joint NSF funding. There's a new company out there, Revelar.net, right? And so they give me an example of how I could actually look and understand what a commercial network might be doing, right? So, and this isn't just for them, but this is sort of a little bit of a roadmap here, is to say, it's the user responsibility to assess the environment. Figure out what you can about where you're operating. The user then has the ability to select the preferred option. Right? I said back earlier in this talk, I said, hey, if you're on a particular MNO and you wanted to avoid a particular equipment vendor, that MNO is exactly the right option here in the US. Drive an hour south of the border, that MNO's key partner down there is exactly the wrong option, but you wouldn't know that. Or you might not know that, but you don't have to go with that roaming partner there. Right? You can pick a different roaming partner if you knew the difference. And I'll show you why you can actually know the difference. Right? Then you adapt your communications based on the environment. Right? And you can modify your selections in real time. I think you have to think of this as not static. You don't think of this as like, okay, I had my great MNO here. I drove south of the border. Shoot, my MNO partner is not what I wanted, so I switched to a different roaming partner, and now I'm done until I come back. Not necessarily, right? There's no reason I can't be dynamically switching around. It's a little bit of a different model, but it's a very doable model. All right, so let me give you some actual graphs so you can say, like, this is one of the advantages of being on the funding agency side, right? So, and it's a little bit sad for me. I don't have a lot of good actual data to show you, right? All I can do is fund people who produce really good actual data. But so here's an interesting example. So, could you tell, what network's using what equipment vendor, and how diverse is the network? This is actual data gathered by individual devices, showing you which, what underlying equipment vendors are deployed in what locations. With this phone, I'm tracking this now. And I'm learning like, oh, wait a minute. Oh, look at that. I'm right here in San Diego. Why would this, and so, now wait a minute. There's a lot of stuff that's not filled in here. Why do you think that this map is so sparse? I mean, this is, boy, they should probably do a better job gathering data, shouldn't they? I mean, we funded them, on the NSF side. So maybe I go back. This is entirely user-driven data. This was not a scan to say like, let me go off and do it. This was like, hey, you put this on your phone, give me some data. This is a great example of sort of generating that data from multiple sites. And so, that's, and it gives you a lot of visibility to say like what kind of, so I claim that, with one provider, when I'm up here, I'm on, equipment vendor A. When I'm down here, I'm on equipment vendor B. How do I know that? Not because I went into the data center and looked at what was on the nameplate of the boxes, not because I looked at a marketing or regulatory brochure. It's people went down and measured it. And you can do that in real time, and you can adapt in real time. Got one more interesting one, right? Which is to say, here's another one as you might be going through, say, the Panama Canal, right? And you can adapt in real time. Now, this information doesn't tell you, one color is good and one color is bad. It tells you one color is purple, one color is red. You should adopt accordingly, right? And in fact, you could use both. And maybe using both, you can be even more powerful. So that's sort of my main message here is think of the infrastructure as an adversary, but think of that as like, doesn't mean I get off the infrastructure. It just means I need to do more measurement myself, more selection myself, and I can go forward. I'll leave you with a few last things, almost required as a funding agency group here, right? So we do have a program at NSF on called CC. Cybersecurity Innovation for Cyber Infrastructure. Very interested in seeing some FutureG 5G stuff there. Now, one important distinction on this, though, right? So this is where, and we've got SASE folks in here as well. We coordinate well, right? So if you have a great solution that is going to revolutionize the way you do the cyber infrastructure, you should send it to SASE, and they are really good, and they will, if what you have and what CC comes in and do is say like, no, we're not competing with SASE to say like, well, we got a better 5G solution than you did, right? So, but what CC is looking at is more of the infrastructure you need to conduct the research. So if you're thinking about like, this is something that would be tremendously useful for MNO A, MNO B, vendor A, vendor B, send it to SASE. You can also look at TIP. TIP, if it's more applied, you can look at TIP. If what you've got is an idea to say like, what we need better tools to let researchers understand how this works. We need better ways to do secure simulation. We need better ways to for CC, the main group that you want to say would really love this result are the researchers in this room. If this is something that infrastructure then send it in there. If I intrigued you at all about what it means to be AI cybersecurity, right? That's an active thing. In fact, within NSF, we've just elevated sort of an AI director. In fact, Ellen Segura, who I think many of you know, Ellen is now kind of leading some of the AI efforts across the entire NSF institution, and There's a lot of good AI challenges there. The challenge I'm worried about, and that many of us are worried about, is the cybersecurity aspects of AI. What do we need to be funding there? So and that, you might say like, oh, no, cybersecurity of AI sure sounds good, but I'm an RF engineer, right? I'm not, I'm worried about power levels and, but you still have an interesting role here, right? Because look at what's happening with the RIC. Look at what's happening with Open RAN. Look at this. AI is coming in and it's adapting your system. What do we need to do to make sure that's secure, right? A lot of interesting efforts on support for standards. We'd like to, we keep collaborating, and I think we're close to actually finally pulling the trigger on one of these with OUSDRE, or with the FutureG team, on providing better support. I'll say one last story here, and then I'll go to questions. Right. So my old advisor is highly active in IETF, and so I was asking her sort of like, okay, how do you manage to do that, right? And and it's a really important thing. You apply this to 3GPP. It's very hard to do on traditional NSF funding. And my claim, you can disagree with me, find me afterwards if you, my claim is there are three big barriers, right? Barrier number one is it's not clear that you get much academic credit for a standard. I was in a promotion and tenure committee. I was co-chair of a promotion and tenure committee where somebody had an internet RFC, internet standard. And as it went up to the dean level and beyond, the question came back to say, hey, this publication here, you didn't identify whether it's ACM, IEEE, what is it? We're like, it's not, it's IETF. They're like, is that part of ACM or IEEE? No, it's not. They're like, oh, then it's service, not research, right? Now, we're getting better at that, but one thing that we want to do is we think that having something like a OUSDRE or a NSF certification to say like, so that I can come back and say, not this is IEEE, ACM, whatever, but to say, oh, this is NSF. Okay, that counts. Folks know how to do that. So one challenge in the standards is, we need to do a better job of conveying to the community that is important, right? And there's some good things from CRA that are better describing how to include standards in promotion and tenure. Second important thing. All right, so one, we got worried about credit. Number two is the timing does not line up well. I am going to be really scared if you put in your CC proposal that, one of the things I'm going to do in this CC proposal is I'm going to write a new IETF, I'm going to write and finish a new IETF standard in this 2-year CC proposal. You're not going to finish that in 2 years. I picked on the DNS security standard earlier. I'll tell you, so way back, long ago, we were working on DNS security. The DNS security piece is perhaps, in theory, the easiest standard to do. What do we need to do? We need to authenticate DNS information. I ask, what's the IP address of blah, blah, blah? You need to return me a secured thing. All right, what do we have? We have public key crypto, right? Okay, but public key crypto, how do you learn the keys? Oh, wait a minute, we have an inherent structure. There's a root, and then there's a com, and then there's a something.com. This is trivial, right? Everybody knows a root key. We already know a root server already. So all we do is tell you, here's a root server and a root key. Root signs com signs, dan.com, done. I mean, this is almost an undergraduate semester project. If you've taught somebody networking in DNS and you've taught them, cryptography, you say, hey, by the end of this class, secure DNS, right? And so that was the plan, right? Only about I forget whether it was 1 or 2. It was more than 1 decade. I think it was less than 2, right? But that's the time it took, and it's still not fully deployed, right? Because standards are a slow process. You have to get agreement in there. You have to go through these, and so the timeline doesn't line up well. So we have to find a way to give you credit, number one, and to better align the timeline. Because if you send into CC or SATC a proposal saying I'm starting from scratch, and the main deliverable at the end of this will be a new approved internet RFC. I hope my I hope my panel, and if not my panel, I am going to say, like, I worry about your timeline, right? Okay, so we got that, and then finally, if you can't get that funding, where does the funding come from? What I've heard from folks who are active in the standards community, and this is how I did it as well from folks, is that they're doing this based on gift funding. They're doing this based on external industry funding, which is great, but which is challenging, right? And so we're trying on the standards to help you with both the credit, addressing the timeline that we can't we can't say 6 months, please go fix DNS. That's not and then of course we want to look at that funding stream. So we're active in, if any of those three kind of resonate, happy to talk more at the break. With that, I've kind of left hopefully intentionally time for a little bit of questions if there are questions, concerns. But main takeaway, in your next threat model, don't just say there's a bad insider. Say the whole system's out to get you. Yeah, thank you.
Thanks for the great talk, Dan. I'm Yongdae Kim from KAIST. So I know many people in SA3, which is the security part of the 3GPP standard. Yes. And there are, as you said, there are two different kinds of problems. The first problem is sometimes they standardize it still knowing that this is vulnerable. So yes. There are cases like that. And the decision is made by someone beyond the regular members.
Absolutely,
that's
yes.
One case. And there's another case is actually like a RAN or core part of the standard body pushes insecure design.
Yes.
But such design is actually maybe for efficiency and those kind of things so that the secure SA3 cannot actually control. So these two cases are actually very, very difficult, and there are quite a few actually standard vulnerabilities
Absolutely,
in
yes.
5G where we can actually give any impact. And it's actually, what I know is that actually many of our research paper is read by 3GPP SA3, and they discuss about it. But in many cases, they are not being patched, and they just discuss about it. Okay, there is no good solution. Okay, let's move over. That's what has been the tradition.
Absolutely.
And another thing, the last thing, we will use 5G for another 20 years, but the standard is already fixed.
Yes.
That means we have a forever day vulnerability for another 20 years.
Absolutely.
So we need to have some solution to actually solve this problem.
I completely agree. I think that those are all great comments, and 100% agreement on that. And we can. So that's a very hard problem to address, right? It's great that there are standard bodies that are actually looking, like SA3 is actually looking at some of the papers, making that next step to include them. That's a hard challenge, right? Because you have both sort of benign neglect. As I think you said it better than me. You have sort of benign neglect where we probably should do that, but we're not. And I think you also have some amount of intentional neglect. Intentionally pushing this forward, and that's not necessarily. I don't want to attribute that to parties being malicious. Parties have interests, right? Economic interests, and so if I've invested a ton of money in a particular type of system, and I have an economic interest in saying, don't put in the standard something that will make it impossible for me to do this. Don't put in the standard something that will make it impossible for me to comply. I think I don't have a good answer for you on that, but I think one thing that we are very interested in doing is how do we get academics in there in a more influential way? I'm not Pollyanna that we're not going to say like, you know what, they're going to see a paper from this workshop, and that's going to make people think like, you know what, I should have done input validation for my real-time RIC differently, and now I will. We can't. But I think the more we can bring that in there, I think one thing that the academic community brings that provides a lot of security value is we aren't as invested in the economic results. Right? As academic researchers, it's much easier for us to go in there and say like, this is, from a security standpoint, this is the right thing to do. We aren't tied by like, shoot, that could kill my Q3 or Q4 earnings, or or long term. So I think the more involvement we can get from the academic community, the better. But let's not overstate that to say like, all we need to do is go provide some really compelling evidence, because that's evidence there. Yeah, I don't know. But there is their work. I see Ted here in the audience, and folks. There is active work at various government agencies, U.S. and elsewhere, to say what can we do to better influence that. And the other thing is, you're right. I mean, not only is 5G baked. I mean, I think 6G is not. 6G is not a blank slate where we're kind of. So, how do we? So, sorry, I don't have a. Other than that's a great problem, and you're spot on. Yeah.
So Dan, fascinating talk, very interesting. So Ted Woodward here from the FutureG OUSW group. And I was reflecting on your themes and thinking that there are analogs to human systems here, and I'm wondering if you see anywhere that's different. So for example, the corrupt operator as compared to the individual insider threat seems like it's organized crime compared to an individual burglar, right? Organized crime is obviously much more difficult to defeat than individual actors. The standards body is like the legislator, and the red team is the police. And the monitoring and visibility that you point out of being able to observe what's happening in the system is the free press.
I like that. Those are really good.
Do you see any attributes where this might be different from that?
So I think all those are good analogies. The first one is but this is the difference between organized crime versus individual actors, right? And I think that's a great analogy. But I agree with 90% of it. So here's the thing: if I'm going to try to protect against a bank robber or something like that, it's one thing to say individual bank robber. It's a different thing to protect against an organized crime unit. I think where I would. The only 10% difference is I would say that the organized crime group doesn't also have an incentive to provide a service. The one place where I agree with 90%. That place I disagree is the organized crime group isn't in there also trying to. They're not also trying to sell to customers. They're not trying to be their own organization. They can be simply, we want to burn it all down, where the infrastructure provider wants to burn the other guy down, but wants to make sure that it doesn't all burn down. But I think those are great analogies.
I would ask you to consider the rubbish disposal business.
Yes, I think that's that's I think actually that's probably that makes a lot closer, because in the end, the rubbish disposal in the Northeast still needs to get rid of the trash, right? So that's I like that.
And the loan shark.
The loan. But I think the best. I like kind of the focus there. When you said organized crime, I was thinking a different way, but I think the trash in the Northeast is exactly the right is exactly the right analogy. What I like about that is, no matter what happens, you still have to get rid of the trash, right? You can be as malicious as you want, but at the end of the day, if you don't haul away any of the trash, you're still, you're not, that bad group's not going to work. Same thing, I can be as malicious as I want as, Dan's M&O, but if I don't deliver some quantity of service, Dan's M&O doesn't exist. But yeah, I think those are all good analogies. Thanks.
So Dr. Massey, Dan, thank you so much. Very insightful talk. So I want to, thinking about this, I want to check what your thoughts are on creating agentic AI red teams. See, you brought up the thing, right? Red
okay,
team for AI, right?
Yes.
So what do you think about creating an agentic AI red team based on Claude to watch OpenAI, and the other way, OpenAI-based red teams to watch what is Claude doing? What are your thoughts about that?
Yes, I think that actually that's a great direction, right? I think that, we want to, yeah, so I think, I'll take this slightly, all right, so when we're focused on with the national academies, and this isn't quite Urup's question, but we are making a clear distinction between AI for cybersecurity and cybersecurity of AI, right? So, there's great work, but I'm not so interested in how can I use, how can I use AI to better do anomaly detection and better blah, blah, blah. People should do that, but that's not the challenge. Except there's a twist here. So if it's using that AI, if using agentic AI to monitor my network and detect anomalies, good work, but not exciting. If it's using agentic AI to monitor the agentic AI, then I'm interested, right? And I do think that we will have to get to that point, because I think part of the challenge that a lot of the security challenges we're coming across here are a factor of scale. And I think we're going to have to use agentic AI to address the security. I'll give you an unrelated example that comes from the astronomers. Right, so NSF is bringing on new astronomy data, and so within a couple months, they'll be bringing on stuff that's monitoring the sky, and it's going to be generating what the astronomer program director has estimated as 10 million alerts per day. All good data. There is no amount of grad students, postdocs that you can use to monitor 10 million alerts per day. So we're going to be using AI to monitor the data, right? The old approach was to say, like, okay, this is great. I'm going to, in a scientific study, I use AI to kind of find that, but then I will go in and I will do the human curation, human value, validation. At 10 million a day, I can't, right? And so can I build AI? So I've got AI generating the data. Can I build more AI to analyze the data? And can I build yet another AI to analyze the analyzers of the data? But yes, I think you have to apply, and I think that has to be part of the red team. Frankly, I think, 10 years from now, I think if you have a red team that doesn't have agentic AI in there, I think they're yeah. Thanks.
Let's thank Dan one more time.
Thank you.